Well, I'm glad to see that people are communicating and sending me questions. And I've got some more questions to go over on logs. And we'll start with 6.383. 6.383 slash 34. And here's the question. And this is a good test question. I like putting rewrites and equations on the logarithm test. I think I probably say in the videos that 80% of your logarithm test is going to be rewrites and equations. And this is a rewrite because it says rewrite the expression as a single logarithm. And it says write, but it means rewrite. You're rewriting this in a single logarithm form. So this one says, I'm going to write it down. This one says negative 2/3 log base 3 5m squared. Now, why did I put parentheses around that? Because that's what you're taking the log of. So that might be important when you're rewriting, so you know what you're taking the log of. Plus 1/2 log base 3 of 25m squared. Sorry, that's, oh shoot, 25m squared. There we go. Okay, so just ignore that. Just ignore that. All right, so the first thing you're going to do, you can't do anything with those fractions there, so you're going to use the power rule and take that there and there. So that's going to be log base 3 of 5m squared raised to the negative 2/3 power plus log base 3 of 25m squared raised to the 1/2 power. Okay, that's using the power rule. Now we're going to use the product rule, and we're going to write this addition as a multiplication of two terms. So that's going to be log base 3 of 5m squared raised to the negative 2/3 times 25m squared raised to the 1/2. Now what? Well, now I'm going to distribute that using the power rule of exponents. Power rule of exponents. This is the product rule of logs. This is the power rule of logs. And this is the power rule of exponents. Distribute there. And there, I'm going to put a baby step in here for you. 5 to the negative 2/3. M to the 2/1 times negative 2/3 times 25 to the 1/2 times m to the 2/1 times 1/2. Now I put that baby step in there because it's fractions and y'all don't know how to read a tape measure, so some people have to have, help with fractions. So I'm going to combine my 5, turn this into a 5. Let's go. Square root of 25 is 5, so log base 3 of 5 to the negative 2/3, m to the negative 4/3, 5 to the 1, m to the 1. And now we just add exponents because we're still multiplying. So log base 3 of 5 to the negative 2/3 plus 3/3, and m to the negative 4/3 plus 3/3. I'll leave that up for a few seconds so you can hit the pause button. And here I'm using the product rule of exponents. And I'm going to carry this over to the next page. So I'm just going to move this up a little bit. Okay. That's going to give me log base 3 of 5. Negative 2 plus 3 is 1/3. M negative 4 plus 3 is negative 1/3. So using the inverse rule, I'm going to take that downstairs. And that's going to be log base 3 of 5 to the 1/3 over m to the 1/3, which is log base 3 of the third root of 5 over m. And that is a good test question. So I'm going to bring it all the way down so you can look at it, and then I'm going to move it up again so you can pause the video. That's it. Next question. And that's the answer. Log base 3 of the third root of 5 over m. Next question. 6.4, 1/1. 1 in the book and 1 online. First of all, is this a test question? Could be. In fact, it's a pretty good test question because it shows you the whole thing about an inverse. And let me go ahead and, okay, something just went crazy with my, once in a while something goes crazy with my computer. All right, they say the graph to the right is the function, and they want you to do the inverse function. Well, there's two ways you can do this. You can do it graphically, or you can do it algebraically. Algebraically, you got f of x is equal to 5 to the x power. That's right here. If you can't see it, it's right there. So algebraically, let me write this down right here. Algebraically, you would go, okay, we'll change this to a y, 5 to the x. Now switch the y and the x. That's going to be x is equal to 5 to the y. And now you got the definition of a logarithm. And the definition of a logarithm says this is equal to y inverse equals log base 5 of x. And that is the inverse function of that. So this is your function, and this is your inverse function, which that, you can't do this on a calculator, so you got to do log, change base formula, over log of 5. And now you can graph these two on your calculator. Graph this one versus this one. And you can do it on your calculator and see what it looks like. Or you can use the graph representation. Okay, this is how you do it algebraically. Okay, if you do the if you do the graphic representation, if I could find the question, there we go. And I'm going to redraw the graph, and I'll show you what I'm doing here. I'm just going to redraw this graph. I'm going to draw it big so we can expand it. We've got a point at 1 and -1 and 1/5. So -1 and 1/5. And logarithms always cross at 0, 1. So this is 0, 1 right here. And then we got another one at 1 and 5. And this is your f of x is equal to f of x is equal to 5 to the x. Okay, so how in the world do you do this graphically? Well, with the inverse, the y is the x is the y. In other words, it's fast backwards. So I got to turn this around, and I'm going to do 1/5 -1. I'm going to turn this around. It's going to be 1 and 0. I'm going to turn this around. That'll be 5 and 1. And I'm going to graph those points. So let me go ahead and show you the whole thing. There we go. And that's true with any inverse. The function, if it's -1 and 1/5, then you flip them. 1/5 and -1. So 1/5 is right here. -1 is down here. So there's that one. I'm going to do this in orange. That way you'll see it better. And then 1 and 0 be right there. And then 5 and 1. 1, 2, 3, 4, 5, and 1. And that function looks like that. And you can see that it's going, and there is always a line of symmetry between the inverses, and it's usually at, y is equal to x. It's usually that. And you see that they're inverses of each other. And it asks you domain and range of the function right here. Well, the domain is from -infinity to +infinity.
Priority 1 message coming in on secured channel.
I'm sorry. No, it's not. You can't take 0 to infinity. It doesn't touch 0 either. And the range is from -infinity to +infinity. Because it keeps going down that way. And it keeps going up this way. So, and it's increasing from left to right. Which way do we read? Left to right, it is increasing. And that's all you need to be able to do on that one. It's a good test question. I like it. The reason I like it is because you can do it algebraically and then put it on the graphing calculator, and graph this one versus this one. Or you can do it on the graph that they give you and put those points in and have your graph look like that. So either way, you are doing it either algebraically or graphically. Okay, that's that question. Next question, 6.435. 6.435/16. F of x is equal to, they give you a function. F of x is equal to log base 1/3 of x. And they want you to compare it to f of x is equal to log base 1/3 of negative x plus 7. I have no idea why they write it like that, because that's not the way you write algebraic equations. You write it like this. But, you know, that must be some of that new math. All right, so you got to do change base formula. Change base formula says f of x is equal to log of x over log of 1/3. Put that in the calculator. And then over here, f of x is equal to log of negative x plus 7 over the log of 1/3. And put those two in your graphing calculator. And let's see, the log of x over the log of 1/3 is going to look something like this. And I'll do the other in orange. Okay, so that's this one. And this one I'm going to do in orange. But notice, now with the logarithms, the horizontal shift is positive 7. And it's going the opposite direction because of the negative. So the negative tells us opposite direction. And the positive 7 with logarithms means 7 to the right. And so that means I'm going to be 1, 2, 3, 4, 5, 6, 7. It's going to look something like that. And of course, you could do that on your graphing calculator. Once you put it in the change base formula, you can put this in the calculator and then put that in the calculator. And I think I did that for you. And the two that we're talking about is the green and the orange. See the orange? It's going that way. Hold on. Move this down. Well, you can't see it. Okay, here we go. Okay, the orange is going that way. That's our black right here. Orange is the new black. And the green is going like this. So you can do it on the calculator, or you can do it by, you know, like I just did it. However you want to do it, that's up to you. That's a good graphing. I like that as a test question because you can do it on a graphing calculator, or you can do it, you know, right here on by hand. Either way, you know, you can do it. Next question. Six 6.451/21. 6.451/21. And this one says f of x is equal to 9 to the x minus 1, and they're going to probably ask you to find the inverse. So we'll do that on the sheet here. Algebraically, y is equal to 9 to the x minus 1. Switch the x and y. X is equal 9 to the y minus 1. And it looks like you could actually do x plus 1 is equal 9 to the y. Now you got the definition of a logarithm. A to the y is equal to x. Okay, I'll write the definition of logarithm up here. Y is equal to log base a of x yields a to the y is equal to x. And that's one of the first things I talk about in my videos. If you don't know the definition of a logarithm, you don't need to take the test, because the definition of a logarithm can be used to solve equations, to simplify equations, and it's just a tool that if you don't know it, then you're in trouble. So A, it's going to be log base 9. Log base 9 of what? Well, x. X is x plus 1 is equal to y. And you put this in a, so that's y inverse, because we're finding y inverse is equal to log of x plus 1 over log of 9. Put it through the change base formula. And that, algebraically, is your y inverse of 9 to the x minus 1. And you can punch this one in the calculator and this one in the calculator and compare them. Or you could just go over here and say, well, 9 to the x minus 1, that's going to be going in the opposite direction of 9 to the x. I'm sorry. It's going to be a horizontal shift of 1 down. So, and there it is right there. And that's, instead of crossing at 1, where they usually cross, this is a 9 to the x, a 2 to the x. And that's my phone. And it'll be 1 down, so it'll be crossing right here. I'm doing something on the recording. What do you need?
Can you pick me up a little bit later?
Yes, let me call you back. Bye-bye. Sorry about that. And then we know that that's that function. So this one's going in the opposite direction, so it's going to be going something like this. And that's why you got the, I'm sorry, it's going in this direction. So you've got the blue line right here. Let me go ahead and clear, since we've already done this right here. Let me clear these. There we go. And the blue line is your 9 to the x, and the purple line, or the magenta line, is the log of x plus 1 over the log of 9. And like I say, once you do it algebraically, you can just punch it in the calculator, because nobody expects you to be able to graph these, because it is logarithms and they are a little bit funky when it comes to doing the calculations. And let's do the last question, and that's 6.561/17. So 6.561/17. And this is going to be a test question because it is an equation. And anytime you have an equation, it's going to be a test question, because equations and rewrites, what I like to put on the test. This one says the square root of log of x minus 3 is equal to log of x minus 3. Now, when you look at this, something should stand out. What do you mean something should stand out? Well, look at it. What stands out? They're the same one, except this is the square root. Well, there's only 2 numbers in the world that you can take the square root of and you get the same thing. The square root of 0 is equal to 0, and the square root of 1 is equal to 1. So one of these has to be 0, or one of them has to be 1. Either one, So I'm going to set one of them equal to 0, and I'm going to set one of them equal to 1. Now, you could set each one of them equal to 1 and each one of them equal to 0. That's just extra work. So I'm going to set one of them equal to, I'm going to set the log of x minus 3 equal to 0, and the log of x minus 3 is equal to 1. And the reason I'm doing that is because this is the same equation as this, only it has a square root, and there's only two numbers in the world that you can take the square root of and get the same number. And that's why I'm setting it equal to 0 and 1 to see what we get. All right? So let's solve. Log of x is equal to 3, and log of x is equal to 4. Definition of a logarithm, this is base 10, this is base 10. So 10 to the third is equal to x, 10 to the fourth is equal to x. So my solution is 1,000 or 10,000. Exponent means how many zeros you got. So this one has 3 zeros, this one has 4 zeros. So if you plug 1,000 in right here, you're going to get the same answer over here. If you plug in 10,000 right here, you're going to get the same thing over here. So your answer is 1,000, 10,000. That's a good test question because it's kind of short and sweet once you look at it. $10,000 or 1,000, 10,000. And those are the questions that were sent in. This is the second virtual office hours this week. So y'all are busy. Glad people are sending questions. Communication is the key. Those of you not communicating, I don't know. I don't know why you're not, getting more bang for your buck. That's what the teacher's here for, but you're not sending any questions. So I don't know what's up with that. Maybe it's something to do with Tide Pods. Anyway, y'all have a good day.